we will restart or resume the presentation from Linkar about the installation today of the server side. So basically the broker that acts between the client and the users, or the user's client, sorry, and the hardware servers that are the devices that control the experiment. And I'll give the floor to Rui. As usual, Anna will put on the chat the document for you to sign as in Tuesday. I have some people asking me for the video. As you have seen, there is some glitches on the grab session on Tuesday, and I have asked Linkar to make some cuts, trying to reduce to the juicy part of the video, so we don't spend so much time in rewinding and feed forward the movie. So they will cut the parts that are not so relevant, and eventually to put some slides in the middle to clarify some aspects that you should be aware of. Okay, so I don't know exactly when Linkar we can do this, but probably within 1 or 2 weeks we are going to have it available. The last thing I'd like to ask you is we are in a critical phase now, because starting on the 15th of March we are going to have again the MOOC running, and actually I have not only people from Brazil, but like Cristiano, just we spoke today about this, but there is a couple of pendulums that lack on the calibration, or eventually they are down, and we need these pendulums working for the training. So don't forget, please, that we are going to have 2 critical moments. One is the 5 weeks starting on the 15th of March, and then later in April, because we are going to have the MOOC run on Spanish. So I'm going to send an email mainly for the managers before day 11. We are going to have a meeting with the managers. A couple of them probably are there. This is not the meeting for them, but I suppose they are here in the starting of the meeting. But anyhow, I'll try to send a list of the pendulums that are not working properly, and they need to be repaired. Pendulums that have been arriving. So I need an effort from you to have it ready and running during these 5 weeks starting in 15th of January. Okay, so now I pass. I don't know, Anna, if you want to comment something, or you are okay?
I'm okay. I'm just, please go to the form and register, but you already said that. Okay, but I'm okay.
Okay, don't leave it for the last minute.
Oh,
I think
and I'm going,
time.
Yes, just saying, I will record this. So do you want to start now and you do this reminder?
Not critical, the reminder. I think what is very important is to record the session starting with the presentation. So I'll ask now you to start, and I give the floor to Rui, okay?
Thank you.
Hello, everybody. Thank you, Horacio, for the introduction. I'm also recording. Hope everyone's doing okay. Pertaining to the last session, I'm going to share my screen, and the idea is to revise a little bit what we have done. Can everybody see? Let me know if you have any problems.
It's okay, Rui.
Okay, thank you. All right, so continuing on what we had done on Tuesday. Just a small recap, very quickly. This is the architecture for the software that we are assembling. And today, as Horacio said, we will be entering into what you will need to place in your servers, in the servers that the project that you can acquire via the project, and what will be their function. So this is a little bit the layout. If we consider the architecture that we have, you will find that there's a piece, the reg hardware server, along with the driver. This software piece will be housed in Raspberry Pi, usually, as a standard for the project. So this will be housed in the Raspberry Pi that goes along with the Pendulum. The rest of the architecture, the multicast controller and the client, will be installed in your servers, in the partner servers, okay? And this is what we're going to take a look today. Before we go there, I'm going to start at the beginning a little bit. So we had kind of three main steps, which were if we wanted to put a Pendulum online. The first one was to build. The second one was to deploy. Sorry, the first one was to create the Pendulum. The second one is to build the project. The third one is to deploy the software pieces. So I'm going to recap a little bit very shortly what we had done. On this aspect, to create a new Pendulum, we've created then a script that will help you create a new Pendulum out of scratch. I can also say that you don't have to just create a Pendulum. If you want to create some other experiment other than a Pendulum, you can also use the script. So as long as you go to the folder that has been created, to the experiment that has been created, and you change everything accordingly. I will remind you the hardware info with information for the hardware, the channels, or the parameters that represent the variables that we're going to configure on the experiment, and then the channels would represent the variables that come from the experiment towards the client. Our Rs232 Config Xml defines and configures the communication port between the Pendulum and the hardware server. Then you have the customizer and the displays that are software pieces and the graphic user interface that the user will use to customize the experiment and to view the results. Then you have the regface config XML, which will bundle up all the locations of the various elements that will form the graphical user interface. So you're going to need to supply the displays and the location and the labels for the customizer and for the different displays. And then you also have a messages.properties where we centralize all values for labels and names and locations in a centralized way so that it's easier to manage. After you've done this, you can prepare the build files. Special attention to these two if you're changing system variables, if you're changing locations, if you're changing the servers that will be playing these roles. So where the multicast will be, where the client will be, where the video will be. So have some attention to these properties files. Just run through them. Everything is pretty much self-explanatory. And once you're done with all these files, you can commit them to Git. Okay, you can save them on Git, and you can build your project. Okay, so at this point, to build, you can use Maven and Unt. You should use Maven and Unt. The frameworks to build. I remind you also that this is using Java 11, so you're going to need JDK 11, Java Development Kit version 11, besides Maven and Unt to perform the build. The instructions for the build, I say it later, I don't have it here on the slide, but the instructions for building the project are present in a README file within the project. Okay, so just use the README and you'll have instructions there on how to build. Then this is the overall command to build the project, and then to push the artifacts that are created, push them into a Docker repository. Okay, usually we use Nexus repository, but usually push them to those repositories before we make the deploy. At this point, and picking up also where we left off in the previous session, I would invite my colleague João Portes to present a little bit also similar to what we done last time, to present the creation of a new experiment using the script, and then the deployment, the building and the deployment of that experiment. Koch, would you like to take that on?
Okay. So we are trying to remind me. We are trying to now do what we tried yesterday.
Yes.
Okay.
Yeah. So we're going to build to create a new experiment using the script for that effect, and then build the project with that experiment, and then deploy the hardware server and have it running. Just a small note that when we deploy the hardware server, the instructions are here at this link. A small note that we enter into this today, we're also required to do the deployment of the client, but we'll get to that in a minute. I would invite them, João Cortes, to share the screen and from there show you how the process can be done.
Okay. Okay.
Thank you.
You need to stop sharing, Rui, but I can do it for you as yesterday.
I think I managed.
Okay.
Did it work? Yeah. Okay.
Yeah.
Okay. So we are going to try creating a new experiment based on what we tried yesterday. We just made a few changes because of the issues we are having. We added an optional value to describe the serial device that is going to be used. By default, it uses this device, but sometimes you maybe need to configure another one. So we have the possibility to replace that in our experiment. So
Yeah.
now.
Sorry, João, let me just a small note to complement what we are seeing. João has run the script. As you can see, there are a number of variables that are being requested as soon as you ran the script. So on the screen, you're going to have instructions on how to run the script. Okay, so it's asking for the experiment name, the experiment ID, which was what we talked about in the earlier session. This ID that must be common between every one of these elements. Then the location, the video location, and the serial device, the serial port that will be used for the communication. So that's what João is showing there.
Yes. And if you don't define the serial port, it will automatically define this one. It's the default one. So I'm going to show. Yes.
There's someone asking if we can increase the zoom.
Okay, sorry. Okay.
Yeah.
Is this okay?
I can
A
see.
little more.
Thank you.
Yeah. Okay. So now we're going to try to create another country. I tried a little before to create for Spain, but now I'm going to create for, don't know, I'm going to create any suggestion, Rui?
VAP is Chile.
Okay, Chile, but can be Chile.
VAP is Valparaíso, so.
Okay.
I don't know what means FSCM_VAP, but.
Okay. This one is the ID that is associated with the hardware server, so we must maintain it.
Yeah.
Or the experiment will not work.
Yeah. So basically, and this is what was happening last time, the hardware apparatus is actually outputting this ID, so we need to match it all the time.
Yes.
So unless we will go change it, which would be more complicated at this point because we don't have access to it. But that ID is fixed, so we're going to maintain that ID. The rest we can change.
Yes, I'm going to change also the experiment name, so it matches. So you are seeing a new experiment besides the one the ones that we created, and you can see how easy it is to create a new experiment. Now I'm going to change Chile, and I'm going to pass the serial port that is different in this server. So now I'm going to run the script.
But on
Yes.
Chile, it's S0, TT
Yes,
S0.
yes. See, in that case, you don't have to define this parameter. You can omit it. So we are going where this time we are getting the informations. If we made some mistake, it will show us to what variables are going to be passed in this moment. So we have the video, we have the serial port that is going to be replaced, the experiment name, and the ID of the experiment, and the country, the location. So now, if we can see, we have WP training tree created, and now all we have to do is just run the command to deploy the. We have a repository that we are storing our Docker images at our repository, but in later, I don't know if I can increase this. Okay, no, it's being okay. So don't know if you can see this, but later on, if you want to publish, as this is going to be public, so we can change the repositories. We are using our repositories for publishing and retrieving the images, but later on you can change it by passing these variables at the Maven command that we have here. We can run the command like this, or pass the variable like a docker.io to change this, or we can also change the POM file used by Maven. We can change it so our repository maintains. We don't need to pass it every time. We can change here, but it's easier for now to pass the variables like this in the Maven clean command, Maven deploy command. So now I'm going to publish this new experiment. I'm going with this command. Okay, so I'm not in the right directory once again. With this command, we are going to package the hardware server and all the Docker images and publish them to the repository, to our Docker registry, that it's going to be accessed later. Okay, so I opened the new. Okay, this happens because I have two installations of JDK in this server. I have to pass a variable to say that I'm going to use JDK 11. This could happen if you have a lot of JDK installations in the same computer that you are using to build. So now this takes at least 10 minutes, but the bundle that this packs, just for comparison, you needed to install a lot of components that would take a day, 2 days to install, and 10 minutes is not too much time compared to what you needed to do if you had to install that in your server manually, installing a Payara server, a WebSwing server, MySQL database, all the components involving the rec infrastructure. So now I think I'm going to pass to wait. Don't know if you want to add anything else. This is going to take some time.
Yeah, I can continue with the presentation on this side while it builds, and then I'll get back to you.
Okay. Do you want me to stop sharing, or?
Yeah, probably. Okay. Or just make your presentation bigger.
Okay, pause. Is that okay? Pause share. Okay, I'm going to pause the share.
All right, can you see my screen again? Let me know if you don't see it.
Yes.
All right. Cool. So this is where we are. So João Cortes is using Maven and Node to build this, and Docker to build directly for a Docker repository. So he's using this command. Sorry, let me just get this bigger. Okay, so he's using this command right here. He's building and immediately pushing the images that are created to the respective repository. Okay, so he's doing this in one step. You can divide it if you want to do just the build. You got the command right here to make the build on its own. If you use Maven clean deploy, it'll do everything in one step. So it will build up the project, and then it will take the artifacts and the images that are created, and it will put it immediately on the Docker repository. In this case, it's Nexus repository. Then you have, if you want to change the repository, you can do that, but be aware that we have two different links for that, one with read permissions and one with write permissions. Okay, the repo and the hub. All right, so while he's doing that, let me go through the next steps after the deploy has been finished. And this will be deploying the hardware server package into Raspberry Pi. And then this second step, which will be deploying the remaining images, we'll go to that after we see João doing the deploy of the hardware server. So for this first step of the deploying the hardware server, this is basically what is already shared with you, what has been shared with you in the wiki page, with the instructions for you to deploy the hardware server on the Raspberry Pi. So what we do today is that we make the build, and then the hardware server will be outputted as a zip file. This remains the same as João is doing now, as we are doing now. So this hasn't changed. What happens today is that we take this zip file and we supply it to you via a shared folder that is also for which the instructions for you to copy and access the zip file are also in the wiki. In this case, if you're going to be doing this on your own, what will happen is after the deploy, you will need to access this folder, this Java within the project, this Java, and the name of the experiment, and you're going to have an hardware server, a new hardware server zip with the date for the date at which it was created. Okay, so you're going to have this new zip file there. You need to retrieve it, and to deploy, you are going to need to access the Raspberry, usually the Raspberry or any other server that might be connected to the Pendulum. In this case, in order to make it simple and clearer, I'm going to mention the Raspberry Pi. So you take this zip file from where you build it, you access the Raspberry Pi, and you copy the zip file into the Raspberry Pi. You should try to make sure that there is a directory for deployment. We usually call it home WPA rec deployment. This can be changed if you want to, this folder. If you want to change it, but be aware that there might be a few items in the build properties files that need to change accordingly. So before you change that. But it's nothing too complex if you want to change that. Okay. After that, you move the hardware server, the zip file to that directory. You will unzip it. Okay, we put an example of a command right here, a Linux command to unzip the file. You will go into the folder that was created. In this case, we're using the WP template as an example. And from there, from that folder, you will run the command to start the hardware server. Okay, so once you've unfolded, unzipped, and unfolded the hardware server package, all you need to do is use this command, the start in this case, start WP template driver.sh. This is a bash command to start the hardware server. And what this command will do is that it will run the hardware server application on the Raspberry Pi. Remember, this is a Java application, so you're going to need Java installed there, right? As soon as this application starts, it will try to connect to the experiment. Okay, so the hardware server will listen to the port that was assigned, like João was saying. The port can be assigned in Rs232 Config file, or when you create the experiment, if you want to pass a port that isn't the standard, you can do that with a new script to create a new pendulum. So this port, the hardware server will listen to this port, searching for the ID string that is coming from the pendulum. So it will be listening for this ID string. Once it finds it, it will immediately connect to the experiment, and the experiment should then appear green on the rec web, and the experiment should be accessible online. Okay? If that doesn't happen, it's because in some way or form or fashion, the hardware server is not being able to connect to the experiment, or something else is might be going on. In this case, in this file, in this presentation or the document that I'm showing to you, we have left a series of instructions of how you can debug this, okay, or how you can start to debug this. Okay, it's not everything, of course, but but we're leaving some advice for you on this. But at this point, I would ask João if the build is complete, and then I will continue on this part.
Almost.
Almost
complete. Yes, it's pushing the images to the repository.
Okay. Let me just check if there's any.
I can try to I can also at the same time can try to install the hardware server, because that part I think is already the zip files are already there packaged. So I can try that. Yes.
Okay. In that case, I'm going to pass on to you, so you can show that. Basically, what João will be showing is this process right here. Are these steps right here that I've shared with you? These are also described on the wiki page, and of course, I'm supplying this presentation for everybody to take a look at after the training. But it's fairly simple. So João, I would ask you to share your screen and show us how it's done.
So, okay, just a moment. Okay. Sorry, I think it would be better. Okay.
We're not seeing your screen, so please.
Yes. Okay. I'm trying to share it. Maybe you can continue with the questions. If someone has questions, I'll try to.
Okay. Yeah, I can address a few of these questions just while we make this pause. So Elida is asking if we can use a temporary server and then mount it on a new server. João has already answered this. Of course, you can do this anytime you want. The only aspect that you need to be aware of is that when you're changing servers, you need to make sure, for instance, for the multicast, where the multicast is pointing, it needs to point to where the hardware server is pointing to the multicast. You need to make sure that the Raspberry Pi, in this case, recognizes the new address for the multicast, or the new pathway to whichever multicast you're using. So whenever you make a server change, you should make sure that the server knows the destinations of each destination server. For that end, let me just share again with you my screen.
Yes, maybe you need to rebuild the project with new properties, pointing to the new servers.
Yeah. So I'll be advancing just a little bit because it touches this point that the question was pertaining to. These are some of the network requirements that need to be in place in order for the system to work. So we have here different connections that need to be ensured between all the different servers. So when we say here rec web, this is a rec web server, needs to have a connection to the multicast server. The rec web server on port 25001. Rec web server also needs to have a connection for multicast server on port 9001, etc., etc. And this is these two down here are perhaps the most interesting for you at this point, which, as you can see, the hardware server. So this is the server where the hardware server is installed, which in this case is the Raspberry Pi. So the Raspberry Pi needs to have a clear connection to the server while the multicast is installed on port 9001. Okay, and it also needs to have a clear path or a good connection to the video streamer server on port 80. So these are the connections that need to be open. In this case, from the Raspberry Pi. And if you're changing a server where you're installing the hardware server or any of the other components, you need to ensure that these connections are open. Okay, so this is basically what you need to take care of. And this can be done at server level and also eventually at the build properties files, like João was saying. As long as the variables in the properties files are recognizable by the server, and then the hardware server should be able to find its path, or any other application should be able to find its path. Okay, so this you will need to take some care of and you're going to need to have your IT personnel take a good look at this. Okay, so just making sure that these are open.
Yes, our recommendation is to use a VPN in that servers so they can communicate without firewall restrictions. If they're staying on the same VPN, it is it is safer, and you don't need to
Burn yourself.
concern, yes, with with the port restriction. It is better that way, and you can use the protocols that are more efficient, because UDP uses random ports sometimes uses random ports to allow communication between the servers. So it is better we recommend using a VPN, so you don't need to bother with the firewall restrictions.
Okay, thank you.
Okay, I think I can share screen. Oh, yes. Okay.
Okay, go ahead.
Someone was talking.
It's me. Are you listening me?
Yes.
Okay. It's just for saying that the multicast ports that are in a PowerPoint are configured at build.properties. Okay.
These ports you're saying?
Yeah. It's not a fixed one. Okay?
Yes. Usually these are the standard ports, but they can be configured in the build properties file.
Yeah.
Okay, thank you, Pedro.
You're welcome.
Okay, so now can I share the screen?
Yeah, go ahead.
Okay. So. Okay. I think we have a question from Ernesto Garcia too, saying rec web, multicast server, and stream server could be on the same server. The idea, this part, joining rec web and the other components, is going to be addressed in the continuation of this.
We'll get that.
This session, but. The stream server and the client, the stream server and multicast server can reside in the same server. There is no objection to that. Multicast server is not a resource consuming component. The stream server consumes a little more resources because it is using it is receiving streams from the web cameras and publishing it so that the client can read from it, and anyone that has the access, you can use VLC or some tool like that to access these components, so streamer can be resource consuming. It can be used to streamer server and client can be resource consuming. Rec web and multicast not so much resource consuming with that components. But we will be referring that later in the session. Okay, so now we have my screen is being. Where was I? Okay. Okay. So now, regarding the hardware server, as you can see, I have already the hardware server with the WP training tree that I created before. We have it built, and now we are going to copy this file, this zip file. Don't know if okay. So okay, as you can see in the slide in my right, I'm going to expand a little. So we're just going to copy to our server, to ESD server. Once again, copying to TMP directory. I already have a connection opened here, so the file has arrived here, and now I'm going to copy this file to the hardware server, the Raspberry Pi. That we are using for this training session. Okay, so now it must be here. Okay, we have the hardware server. Just changing my user to the user that, okay. Now it's my network.
Gotcha. If possible, says that when you are changing from the computer to computer to where you are logged in. Okay.
Oh, okay.
So
Sorry.
people will follow you.
Okay. I was sending the file from different servers. I was sending here from my personal desktop, and now copied to the server that has the communication with the Raspberry Pi, and then I copied to the hardware server with the Raspberry Pi. And for some motive, I can. Okay, so this blocked.
Also, make a zoom on the letters. Thank you.
Okay, sorry.
Yeah, that's fine.
I'm going to try once again, but my network connection is not cooperating. I'm going to connect.
Okay, can you make it a little bigger? Sorry.
Okay.
Thank you.
Okay. So now I am at the Raspberry Pi. I'm going to change to the user that is going to run the process. We have a Java process here. We have a Java process running here with the WP training 2 that I was running earlier. We need to stop this experiment that is running. I can show you here that the experiment, I'll go to show in more detail. So now the experiment is running. It's going to show. Okay. Okay. It's running, green. And now we are going to shut down this experiment.
Kort, it's good to explain that you call it World Pendulum Spain, but you are in Liz IST. So this makes
Yes.
probably on the personnel, but
yes, this was the training, WP training that I was configured. I configured the WP training to Portugal, and then WP training to Spain, and now I'm configuring WP training 3 to Chile. So now, as you can see, it is saying that the experiment is unavailable. Now we are going to start up. We are going to deploy the WP training tree. As you can see, I'm creating a new directory. It does the hardware server is not dependent on this directory definition. I'm going to create WP training tree, and now I'm going to unzip the package that I got from the build process. So now I'm going to unzip. Yes, it needs to replace some files. Okay. So now I have the structure mounted. As you can see, we have the file that Rui was saying, Rs232 config. We need to have this ID referencing the experiment ID that was configured in the serial port. As you can see, it is already configured to what is defined there. And then the serial device that is configured also, it's not the default one. It is the TTY-AMA0. And now you can see, you can confirm you can confirm the ID if you connect directly to this serial device. If you check it, it has the ID that we are connecting. If we change this ID, it would not work.
Yeah, sorry, Kort, may I just compliment
Yes.
a little bit?
Yes.
What João is doing right now is connecting directly to the port that the pendulum is communicating, and that ID there that you were seeing is actually the ID string that the pendulum is sending to the Raspberry Pi. Okay.
Yes.
And, go ahead.
And also we need to be careful, because as this is not the default port, we have also to define this configuration. But this is all, as you create a new experiment, this is automatically created. So now I'm going to start the experiment. Okay, WP training tree. Now it's running, and we do not have. We just have a version that is not the same as the system, but it works anyway. We could change this, but it will be a little more work because of the devices that we are configuring. As you can see, the device is now active. It says Spain because we didn't deploy yet the Rec web server, so it's normal. It doesn't change automatically. This is going to be addressed later in this session also. And now, if we come to the client, we need to deploy to also deploy the new client. It is not going to work. I was just showing this because you can advance some work. Okay, so it completed the build process, but just to show you that we can deploy the hardware server even if the other components aren't installed right away. It will not work, as if I start Pendulum Mundial Spain, it's not going to work. But when I install the other components, and I'm going to show you next, when I install the other components, it's going to say where we are seeing Spain. It's going to say Chile. So now I don't. Do you have anything to say at the meantime?
Yes, I can compliment a little bit on what you said.
Okay.
So I'm going to share my screen again, if you can.
Okay, sorry.
Yeah.
Okay.
It's a mixed session today. I expect everyone to see what I'm presenting. So basically, what João was doing were these steps. So he took the zip file, he brought it to the PIC, to the Raspberry Pi, sorry. He unzipped the file, and then he ran this script for starting the hardware server. Okay, so now the application is running. It was able to connect to the experiment. It found the ID it was expecting to find. One of the things that you saw there was when you started the hardware server, there were on the command line there were a number of logging outputs. Okay, so the hardware server will log to the console as you run it. So you should pay attention to that, because if it doesn't work, that could provide valuable information on anything that might be missing, or any problem that might be happening with a port or with a network. Okay, so pay attention to that, please, and use it as much as possible. Also, so I've told you about the debugging part, that the networks should be in place, but there are a few other things that I'd like to address, and that also connect with what João has just shown you and explained to you. So one of the things he did was before running the hardware server, he verified that if there wasn't any other Java processes running and occupying the same port. So I'm going to go ahead of this one, because I'm going to try to follow the order that João showed you. So the first thing he did was that you ran a small command similar to this one. It wasn't exactly this one, but we recommend you to use this one. So if you run this command, ps aux pipe grep java, it will show you the processes, the Java processes that are running in the Raspberry Pi. And that's what you saw there. In red, there was a bit of well, that was one process running in Java when João ran this command. And one of the things that it had right before the process was the PID, the process identification number, or identifier. So he took that PID number and he used the command kill to kill that process. So that was the previous hardware server that was connected to the Pendulum. Okay, so it basically was occupying the same port that we wanted to with the new hardware server. So he killed that process, and after that, he connected the new hardware server. He started the new hardware server that will connect to the port. So this information is already here on this file. We will be sharing this with you, so you can make use of it. So if you want to, you can use this before you run a hardware server. Or if things go wrong, this is one of the things that you can do to check what's going on. So make sure that no other Java processes are occupying that port. Okay. So this is one of the issues. The other issue, if you recall, João also used a short command to connect directly to the COM port that is connected to the Pendulum. That command is here. It's called minicom. This tool is installed in all the Raspberry Pis that we are sending to you, that the Pendulums have. You can install it also if you need to. So this minicom tool has got some instructions outlined over here at this link, which is also in the wiki for the Pendulum. So there you will have different and several commands on how to use Minicom, and you can use it to connect directly to the port and view what is being sent from the hardware to the Raspberry Pi. Okay, so use this Minicom tool. It's very useful to connect directly to that port and see what is reaching the Raspberry Pi, if it's the correct ID string, if it is in the correct state, which should be stopped, or if it's resetted, or if it's not well calibrated, things like that. So you can use this to link directly to the port and see what's going on, what's coming from the port. You can also use it to send some simple commands, some strings, to the experiment itself if you need to, okay, without the interaction of the hardware server. So these are all useful tips that you can use to verify if something is wrong in this process. We advise you to take a closer look at all these tips and experiment with them at some point. Also, the last point here, you saw that João also did this verification. So after unzipping the hardware server, on the folder, you're going to have a number of files that pertain to the hardware server, that belong to the hardware server. One of them inside will be the Rs232 Config Xml, where you can verify what is the port that is being used for the hardware server to communicate. You should make sure that it is at that same port that the ID is being sent from the experiment. Okay, so this should coincide. Also, when you run the hardware server, you use this script start hardware server.sh. This script will verify the same port that is usually configured initially at the Rs232 Config Xml. So if you have changed this in the XML file manually, you should remember to change it also in the script, because otherwise when you start the hardware server, it will not search in the correct port, okay? So this is all just for debugging. If you do the standard, there shouldn't be any problem, expectedly. But in case you run into trouble, this is where you should start. Verify that the port is communicating correctly. Verify that all these variables are well defined and they are coinciding with one another. Okay. So this is information that we will leave here in this file so that you can come back to it anytime you need. Okay. Also, if you run into any problems, of course, you can communicate with us. You can send us an email. We would expect you, though, to every time you need help, that you start by sharing what have you been able to test already, whether it's for the network, on the COM ports, or in Java related issues. What have you been able to test? What have you been able to ascertain thus far? And then we'll help you go from there, okay? So these are all useful tips for debugging, and they will be available for you at this point.
Rui,
Yep.
just one thing, it's for say that you only run with GDK 11, okay?
Yes, I mentioned that earlier. I failed to add that here in the notes. I will be adding that before I share this document with you.
Okay.
Thank you.
You're welcome.
All right. If I'm not sure if there are any questions. I can't really see the chat right now, but I would ask João if you'd like to show us now the final step in the deploy.
Okay. The installation of deploy of the other components, né? Right? Okay.
Actually, there is a question in the chat. Ernesto from UTP is asking if the multicast server and the stream server could be the same server.
Yeah. Thank you. I think João already had an approach to answer that question earlier, but we will be looking into that. We will be looking into that shortly after this part. So that will be a little bit more connected to the deployment of the remaining applications. We'll get to there shortly. Thank you.
Okay.
All right, João, if you want to, go ahead and share.
Okay. I'm going to share my screen once again. And now to do the installation deployment of the other components. We have already the hardware server running. It is not needed to restart this component to deploy the other components. They are not locked, or so to say, not locked to the process, not dependent. So the communication is asynchronous, as we can say. It communicates and it's like fire and forget. So we can deploy each component without being worried of the order that we deploy it. If we deploy first the rec server and then the multicast server and then the client, it doesn't worry, because all you need to worry about is that multicast is available, because it's the one component that communicates, that receives the communication from the other, as you re-showed in the slide, that we need to be careful with the port assignment. But for now, I'm going to this. Okay, we have another question, because could be on the same. So okay, it's an answer. Okay, so now I'm going to install in our server, in development server. We have already some processes running. This just going to put a little further, because it's a lot of information and not readable. Just for you to see that there are a lot of processes here, and I'm going to destroy everything that was created here and creating it from scratch. So now we are going to use the Docker tool that is based essentially on the Docker Compose files. We are using the Docker Compose to orchestrate the services that are being launched or deployed at the server. We have a Docker Compose template. Here at the main project, we have a directory named deployment, and then compose, and then src main Docker. We have there the compose templates that we'll need to run and start the components. In this template, normally you don't need to change anything, because we have the configurations needed of the communication between the components, of the reverse proxy that is set to send the information. RecWeb as a web interface, and we and also the client has the same have a web interface that is not used together with the RecWeb. So we need to, if we don't want to use a lot of ports, we use a reverse proxy to redirect the traffic to those components. And this way, you don't need to worry a lot with this component. We just need to create. I created a Docker Compose training YAML file, so that I can join with the template, just with the differences. The template is the common file that is going to be used with the other components, and we can create another files that are going to be used for just saying what we need different from the template, like exposing ports, like saying what are the aliases that are going to be used by the services. This service is going to use this alias, so that our RecWeb can communicate with multicast without going out to the network and then back inside and having to unblock some more ports. So we are doing some configurations, and also the passwords that we are going to need to use. They are configured here. We have to say what locations where they are located, and also the volumes that are going to be persisted. In this case, with the database as RecWeb as a database for storing data that is going to be needed for RecWeb application to run. So now I'm going to use the template and the training file. I already copied the files to the server. We have here the Docker Compose template and the Docker Compose training. We have both files here with the configurations. We now, as I said before, we now are using a Docker registry. For those who are new to Docker, Docker as a repository for storing the images that we create. The images are all the instructions that are needed for the component to run, all the configurations. In this case, for the Elab client WebSwing, it has the WebSwing component that is an application that serves Java Swing applications, and then we have deployed the client that we built before. Same happens at the Elab server Payara. This one is the RecWeb component, and this way it has a Payara server for those. It's an application server like Tomcat or Glassfish. It has this application server to run the RecWeb application. And some other configurations. It will be advised for you not to use the passwords directly as environment variables. You can pass environment variables for you can pass environment variables to the containers, but it is advised to not use them directly in these files as they can be published. We don't want to get this information published at Git, so that's why we have secret files that will be stored only at the server. As you can see in the server, I have the files needed. I have the files needed for the installation. The process is going to, the Docker Compose is going to look at these files, see the password that is defined inside, and then start the process. So now, with no further delay, I'm going to destroy everything. I think I haven't destroyed already. I just need to run these commands are in the presentation, but I'm going to run the ones that I'm going to run inside it. They are not difficult. Yes.
Can you zoom in a little bit?
Okay, sorry.
Bigger. Thank you.
Okay. Like this. It's okay.
A little more.
Okay.
Okay.
So now I'm going to use what I am saying. I'm running Docker Compose. That is a orchestrator tool to join all these services. You can create your own YAML files with your service if you need. You can run specific services, but that is going to be referred later in this session. But for now, I'm going to run the Docker Compose template and join it with our training file. And destroy what we have here. I'm going to destroy completely, even the database. I'm going to destroy everything. So no, not advised to do this in a production server. So now I'm stopping everything. As you can see, it removed also the database. This was the volume to the database that I was referring before. As you can see, no processes are running. I don't have anything. This is a new machine. This is a new machine for now. What do we need to do to recreate everything that we had, but this time with a new client, with everything that we need to run? I'm going to make a pull. You only need to pull the Docker images if you have pushed to the repository images with the same name, and I'm doing the same version for this test. So I have already images published in my repository, and now I'm going to get the newest ones that I built earlier. You can see we have Nexus to do that. If I could open this, okay. We have Nexus to do this. This is a Docker registry that can be used. You can use the public registry, and then I can go and check the images that I created today. We have here the.
Can you zoom in?
Okay, sorry.
No, it's okay.
Okay, so now, as you can see, we have the rec database. Okay. You can see that this was updated a while ago. It's not the same time as for everyone, but here we are at 15. So it was 80 minutes ago. We have here the proofs that we are not doing anything that is prepared from the session. It was made on the fly. So as you can see, all the images that I'm going to get are published now with the 100 snapshot. And now we have pulled the newest images. And now I'm going to rebuild the system just with this command, if my network allows me. Okay. And now with this command, I start up every process that we need: the rec web, rec client, rec database, rec proxy, and rec multicast. You have all these components running here, starting here. So now if you want to check what is happening with rec web, you just need to address docker logs. -f is to say that I want to follow the logs. And now we have the process, we have the information saying what is happening. It is starting the rec web application. It takes a little time, rec web, but maybe rec client should be faster. Let us see. Rec client. Okay, rec client is already up. We can connect to the rec client already if you want. We can go lab dev. That is where the process runs. Okay, going to start, and as you can see, Chile is now being served. And now if I connect to this, if I connect to WP training tree, as you can see, now we have already the same experiment that we did before, but with the changes with the country, World Pendulum Chile. It has all the information needed for the country, that we set up. If we can see now if rec web got up, rec web. Okay, so now, okay, this is another story. Okay, it is here, deployed correctly, success. These one are another messages, but not important for the training. Okay, so now as you can see, we have the experiment. You can also access this if you want. You can also Okay, don't know Hugo, if you want to pass the the link to the
Yeah,
to the chat, but I can show you that the experiment is working as supposed. In a less than 5 minutes, we recreated a new environment with the new experiment. As you can see, the experiment, my network is not cooperating, but okay. So as you can see, the experiment is working. This is not a screenshot.
Yes.
So we have all the components up and running. RecWeb maybe running also. As you can see, RecWeb updated, and now we have Chile for sure. I hope. Okay.
It takes a minute.
So here it is. State running. My user is there, and now everything is set up and ready to run. This is as easily as it can get. I don't know if you want to add anything, Rui.
Yeah, I would. As you can see, João went ahead and he explained the process for the deploy of every other component besides hardware server. So we started off with the hardware server deployment, and then João has shown you now the deployment of all the other applications in one go, so to speak. So all the other applications are being served by Docker, which allows us to do this. To just orchestrate a full deploy with all the applications in one single shot. We don't have to do that, and we will be going into that a little bit in more detail if you want. Just to say now that all of this requires a little bit of knowledge on how Docker functions, on how it works. And so if you don't have that knowledge yet, then you're probably going to need to learn a little bit about it to make sure that you are able to proceed with this. In any case, we will be at your service to help you out with anything. At this point, I would like to ask maybe Horacio, who's a bit of a co-chair, if you want to have a break now.
Yes, I think we could give like 13 minutes break and we can come back at 3:30 if everybody agrees.
Okay, fine.
Okay,
That's fine.
I'll post on the chat.
So I will stop recording for now.
Yeah, please.
Yeah, thank you. All right, see you in a bit, everyone.
Please don't forget to register yourself, okay? This is very important for reporting.
And I maybe put again the link
Again,
on
once
the
more,
chat,
okay,
because
I will do that.
now we have a long list now of chat today.
Okay. Okay.
Thank you, everyone. See you in a bit.
See you.
Ana, só uma coisa. Pelo que eu percebi, a Wanda vai ao técnico ou não vai ao técnico? Eu não percebi.
É assim, eu não sei quando é que a Wanda vai ao técnico, ela não me responde diretamente a mim, ela responde à Denise. Eu tenho que confirmar isso, era o que eu estava-te a dizer.
Tu não vais ao técnico?
Eu estou na Ericeira.
Yeah. É que eu precisava de alguém que imprimisse aquilo que não tem tone. Epá, aqui em casa já estive a dar aqui umas pancadas.
Mas deixa ver quem é que da minha equipa, o máximo que pode acontecer é só ser possível na segunda-feira ou terça-feira.
Está bem, ou o Sandro, não sei, pedir a alguém que vá, é só alguém que imprima no técnico o label, é que o IPFN eu não tenho a chave da secretaria, então não tenho laser, não me está a apetecer muito e pedir ao Conselho de Gestão que me imprima uma etiqueta, estás a ver?
Sim, não, mas eu vejo isso com a equipa, só que pode ser só na terça, na segunda ou terça.
Ou se tu tiveres lá alguém, eu também não me importo, eu vou lá estar amanhã de manhã, e provavelmente na segunda eu não sei que horas, mas amanhã quase certeza que vou ao técnico, só se houver...
Olá, buenos dias.
E portanto...
Então a gente já combina isso melhor, mas pronto, era isso que eu estava-te a dizer.
Se tiveres alguém no gabinete, traz que me imprimam aquilo que eu trago.
Também. Também.
Vim para cá.
Espera aí. Então vá, até já.
Até já.
Gracias.
So you are ready to resume the presentation?
Hello? Yes, coming up.
Okay.
1 second. Hello.
I don't, maybe we can restart slowly. I don't know if there is people there.
I'm sorry, Rs. Sorry.
No, you can start sharing. I think people are coming. I'm not.
Okay, I will restart the recording.
Okay, so we didn't
Rui,
see
when
the
ready,
Coldplay.
you just say.
Sorry?
When ready, Rui, just say it for take 2 or 3.
All right.
Four. Take
4, yeah, 4. Take 4.
Okay, let's do this.
Okay.
I think because we are great delayed now, I suppose, because.
Okay. Well, welcome back, everybody. So I would like to take you back at this point to what João just showed you. Let me just, I want to make sure I get the right picture. Can you see my screen? I hope you can. Okay, so he has deployed the WP Training 3. And the way he did this is that he deployed the Docker images for the remaining applications and services pertaining to Rec. I would just like to give you a small intro on that, even though you've already seen it happening. So all these services, as you've noticed, they are served or they're delivered in the form of Docker images. And this is so because it enables a modular and more simplified deploy. So, for instance, João mentioned that there's a Payara application server for the client, for the Rec Web, sorry, and also for the client we have WebSwing serving the application. So all of those details, those intricate details and things that are going on in the background, are kind of just eaten up by the Docker. So we've already set it up in a nice, beautiful Docker. So all you have to worry about is taking the Docker and deploy the Docker, and the Docker will basically just do everything you need to do. So we set it up this way in order to try and simplify as much as possible the process. You can get started with Docker if you need to. Over here, you can install it. The main first steps are there, and like I said, you should take a closer look at it probably and learn to use it. So we also come a little bit onto how. Sorry. Whoa. Okay, not bad. So now we come a little bit also into a question that maybe has been a bit haunting everybody for the project is, what are the partner servers going to be used for? And this is exactly for these applications. So the client partners, we are expecting them to be used to deploy the client in the multicast, eventually with or without the database. But if you have multicast, you should also have the database, and for the video streaming server. So we'll be getting into this at this point now, and that will pretty much wrap up the training. So for deploying the client in a multicast, as well as the video streaming server, these can be deployed as different units. So I'm going to show you a little bit of what we have today at the servers in Lisbon at IST right now. This is the structure that we have. So a Raspberry Pi holds the hardware server, connects with a Pendulum, and also connects with a webcam. So the Raspberry Pi, sorry, is basically serving these three components. Now the hardware server will communicate with a multicast server, which is on another server. And the webcam will communicate directly with a streaming server, okay? And this is what we will be going into next. Now in this same machine, we also have the client that you have seen, that you have seen here. This is the client being served in this server. And then we have also in the server the RecWeb API, which shows us the page for the RecWeb and a database connected to it. Also, we have represented here the load balancer that basically just manages requests through any of these components. Okay, so this is the basic setup that we have these days at Technical. It's fairly simple. Also, each one of these is being served under Docker. That's why it allows us to make that one-shot deploy as we've shown you. Okay, so what João did previously was deploy all of this system in one shot. Okay. So now, what are we aiming for, or what does this allow us to do from here on out? And this is a little bit of a desired setup that we can implement. So we would maintain the RecWeb at IST. This would be one central RecWeb that will allow us to connect to all experiments. We also have the database there. But in the partner servers, this is what we can deploy. We can deploy the client with a multicast server and a streaming server for the video. Okay. So this is what we can deploy at the partner servers. And this can be associated directly with one or more Raspberry Pis for the Pendulums. So we'd have the Pendulum with its hardware server and its webcam, and they would be directed at this streaming server or this multicast server, serving the clients for this Pendulum, okay? Or more Pendulums connected to it, okay? So this is the configuration that we can predict for a partner server. And this is what we are expecting everyone to learn and to be able to deploy at your servers, at your local servers, connecting your local Pendulums, okay? The main Pendulums or the secondary Pendulums, that's not an issue. So this is where we want to progress to, okay? This is a little bit the objective, and I understand if there are any questions. But by the way, another setup that we can perform is, since the streaming of video takes a lot of resources, we have here the client and the streamer identified as elements that consume more resources than others. So this should take some care on it. And we have also the option, to have a setup number 2, where we can separate the client and the streamers. So we can have one server serving the client on the multicast, and this would be the overall configuration for it. But a partner can also set up another server if you want to, and that would be our recommendation. that partners can also set up a second server with the video streaming, okay, and only for the video streaming, for instance. So this would take some resources out of the first server, and we would have a better, more robust network. Okay, so that's basically it. These are the two setups that we will be looking for from here on out. Evidently, when we say that a partner can create this setup, they can have a client and a streamer, streaming server in their own server, in their own machine. We can also have this setup number 2, and that means that not all partners need to have this setup. If you only have one server, and if you're interested, you can, for instance, only deploy the client and the multicast and connect to someone else's streaming server. Okay, and for instance, this could be the case for countries or for universities that are in close proximity. I'm thinking like Panama, for instance. If we have two universities in the same country, maybe they can share. One university can deploy the client and the multicast server. The other university can deploy the streamer, and therefore you can do sharing resources, and you can connect all pendulums in this way, in this fashion. Okay. So I think this is pretty straightforward. But if you have any questions, just let us know. Okay, so in order to deploy the Docker images, we leave you here some of the main some of the main commands to do that, and what you need to be aware of. So before you deploy Docker images, you need to take a closer look into the Docker Compose, like João quickly showed you before. You need to manage your secrets and your volumes. The secrets, well, they are your own passwords pertaining to your systems, pertaining to your local setups. So you're going to need to pay closer attention to that, so as not to have your passwords roaming around. Also, the same thing for your volumes. They pertain to your own systems, your own servers. So if you're going to be setting up any configuration on that, you should be aware of that. You should review these. So this Docker Compose file stays with you. It is yours, and it is yours for you to manage. Okay. Evidently, we can guide you and give you some support on that, but you should look at what the Docker Compose file is, and you should learn how to handle and to manage it. Okay. So you can eventually, with this and using the commands that João has shown you, you can deploy clients, you can deploy services one by one, or like the setups that I've shown you, you can have different setups or different combinations of these services. So here is the command to deploy one single service at a time. Evidently, the service will need to know where to connect to the next server. And here, for instance, we see that RecWeb connects to the database. The database connects only to the RecWeb, but the client will need to connect to multicast server and will need to know the streamer. This is we have seen it that the URL for the streamer is configured in the build properties file. But the multicast will need to know, will also accept requests from the RecWeb, so the RecWeb needs to know what multicast it will connect to and accept commands to. Okay. So having said this, this is the command, for instance, for deploying over Docker a client and a multicast, as per this configuration right here. Okay. And at this point, let me just answer one question that has come up. So Elida is asking if each partner will have a NILAB page. That is not the case. We are predicting that IST will hold one central web page, This is a fairly simple page that will centralize the clients. So we think it best for user experience not to disseminate or not to have different pages of this sort. So what we would expect is that you would create the clients on your side, and then they would be centralized on one single web page served by technical. Okay.
But Rui, don't forget that we can have, as this will be web-based, any number of web pages, because if a partner wants to have a special experiment in a MOOC or whatever, he can provide an iframe and put the experiment there.
Yeah.
Because that's why we are using WebSwing now.
Yeah. Okay. And also, yes, that is perfectly possible. It's a decision that I would leave also to the partners, but we think it best, and we recommend it best to have all centralized in one page, so that we are not dividing everything. And in the back end, we'd have these different servers sharing load for the network. Okay, that would be our main recommendation. Also, Jaziel is asking if a secondary pendulum is in a geographically more distant position, if it would be advisable to have its own streaming server. Not necessarily, not for one pendulum. That wouldn't be necessary for just one pendulum, because the Raspberry Pi can handle that. But if network issues are encountered at that particular geographical location, then we can consider that, sure. But it's mostly for the idea of separating the video streaming server and having more video streaming servers is to distribute load, network load, and having 2 or 3 pendulums connected to a streaming server would be, or more, would be the best case scenario. Okay. So for one, yep.
For the case that you only want to test, it's possible to run the rec web locally. Okay.
Okay. Everybody got that? For the case that we were retaining, for testing, it's possible that you can also deploy a rec web locally to test your setup, your local setup. Okay. So the idea for this, so I will go also into that a little bit further ahead. But the idea for this is also that you start first and foremost, for those of you who haven't had more experience on it yet at this point, to deploy the hardware server and to start deploying the client and the multicast server. And we will be here to help you with those processes if you need. This document will be the first starting point, where you have instructions, and also information will be shared over GitHub, where you also have the code, and you can get started from there. Okay, so that kind of wraps up a little bit of this part of configuring the partner servers that we had foreseen. I would now like to go a little bit deeper. If there are no more questions, we would go a little bit deeper into the streamer, to the video streamer deployment. And this is also, we are also using Docker to do this deployment of this streaming server. I would also ask João to take the lead on this part of the presentation as well. He will explain to you a little bit of what we're doing, but in a fairly overall view, what we are doing is that we have already a Docker serving this video streaming server. We'll give you the instructions for you to set up this Docker as well. And then we will have 2 different options for streaming protocols that you can use and that we can set up in the system, so that you are streaming video from the different webcams that are accompanying the Pendulum experiments. So, João, if I would ask you maybe at this point to take the lead on this one.
Okay. Okay.
Yeah.
So this part is a little more simpler than what I was showing before. I'm going to share the screen. Okay, so I already have published a compose, a standalone in this matter. I published a standalone compose file. It's very simple, as you can see. We are using an image that was already created and published, and it's open code at GitHub, and basically what we are doing here is saying that it's named this way. The Docker container is going to be called Registry server. The ports are going to be published. For you to understand, in Docker, Docker is isolated from the great advantage of Docker. Docker is like a virtualization tool, but we gain an advantage because Docker it isolates from the system, the operating system, but not in a way that you have an extra layer. It is using the operating system directly, but it has some security security. How can I say this? Security features, yes. That thank you. That allows to separate the components from the operating system itself. So we for an example, you can run as root user and an administrator user, but cannot see what is running on the host itself. You only can see what the root is using in the container that you run. So this way we have more security. We have, in this case, the network. The only thing that we are exposing to the network is these ports. We are saying that we are using port 80 to publish to container port 80. If we wanted to change to 8080 outside of the container, in the host we would have this network port exposed, and inside the container it uses the same port. It is 80. So it's a way to efficiently be more secure that that having all the ports exposed, and anyone who could attack this container from outside could have full access to the operating system. That would be dangerous. So it's a way to protect our systems and to be more compatible with operating systems, because we can run a Debian operating system inside a CentOS operating system, just for you to have a little more view, a broader view from this matter. So now in this streamer server, we have set it to use a TCP protocol. We are using TCP protocol. We could use UDP protocol and expose other ports. We have all the documentation in this project in GitHub. So in this case, we are using this stream server, and it is as simple as I'm going to show you. We have this server for the streamer. This
Sorry,
is
can you augment?
okay, sorry.
Yeah. And
We have this. Yes.
What's the server you're at? Sorry.
It's at the EST. It's another server at EST that is dedicated to the streamer server. As you can see, we have only one image of the streamer server. It's up for 3 days. So now I can show you. I can send this streamer server down. I can stop it. I can remove it also. I can remove the stream server to show you. The video is going to stop working. If we go, as you can see, our video has stopped working. And now I'm going to show you, just copying the compose file. I'm going to erase everything. I don't need this file, but I'm going to keep a backup. And now I'm going to delete and okay, I forgot. Okay, so now we have the configuration that I have locally, that I have published in GitHub. And now if we want to run this process, it's the same process. If I could take off this minus file, it says that I want to focus this file, but the Docker Compose looks at Docker Compose YAML, so I can run without specifying the file name. So now I'm going to run the stream server. As you can see, now the stream server is accepting streams. It's going to accept streams. I think our server at our Raspberry Pi is not.
Sorry, João, Zoom?
Yes. Oh, sorry. I almost forgot. So as you can see, our process went down because no connection available. We have another tool that can be used also. We have supervisor that can manage these processes. Okay, so I'm not a user allowed to do this. Okay. So now I can check the status of the process. I published it as WP video. As you can see, it's fatal status. I can start it. Okay, start WP video. Forgot the process name. And what he's going to do is run a command, the command that we showed in the slide. We have here the configuration to GST or FFmpeg. As you can see, I'm running this command to publish the image to this URL. So now if you can see, the camera published connected to the streaming server.
You must show this a little bit slower because we don't have time to follow.
Okay, sorry. I'm trying to do my best.
Yeah, I understand, but you know what is running, but people wants to read. It's difficult if you are.
Okay. So
Sorry, let's just recap. Go back to here. You're in the Raspberry Pi, is that correct?
In here I'm in the Raspberry Pi. Yes.
Yeah. And you're using that command to set the video streaming
from the web camera. Yes.
From the webcam to the video streaming server, correct?
Yes. Using a codec, special codec for Raspberry Pi, and this one was I had to build. We had to build this with from scratch. So there is not really a version for Raspberry Pi that has already this codec. So we have to build it with it. We had to build it. But this way is we only use this because of the connection to avoid, as as in the slide were shown in the slide. We had with TCP we can avoid random port attribution, and with UDP would be faster and more efficient. But you can read that information in the slide. It can be more efficient, but it exposes ports, random ports, so it's harder to set up when we have firewall between the servers. So this way we tried this, and now if you can see, there are a lot of properties. If you have someone expert in video streaming, it will be useful because these are some complicated.
But, Coach, if I understood, you are streaming again as a MPEG file. So why not to maintain the GST?
the GST, the issue with GST, we started one process with GST with the GStreamer, but at the time we had issues when the video, our client was accessing the published stream. So we reverted to this, but we have the possibility to check later, because it could be some ports that were being blocked, but this is was the fastest way to put the video stream. But it is advised to use the GStreamer or use the UDP communication, because it will be more efficient. Yes.
And another question is, you have coded on the GNLP that is distributed, and it runs as well in the server, the URL of the video, and presently is a SDP access. So once we change this, my idea is, how can we migrate or have a common video streaming that can use on the old platform and in the new one?
And the new one, okay. That, okay.
Or we are going to distribute a GNLP file that will accept this new format.
Okay, the older format, I think I don't have. I'm not sure, but
it's a RSTP, but it accesses a SDP file, a session description protocol file. Okay,
yes.
That is what you get when you click on the interface on the link below the video.
Mm-hmm. Okay.
So I just want to clarify to our colleagues how this will be managed.
Okay. These SDP files in this streamer server does not work. It does not accept extensions in the published streams, the streams that are published. So we have to see it with more detail. We have to discuss it with more detail to check what we could do with the older ones and the newer ones. But it's open for discussion. Yes.
Anyway,
just one thing. The question here is about running with the Darwin in a EST and the other streaming servers.
No, Pedro. I'm not focused on the Darwin. I'm focusing that the distributed version presently of the interface will try to access an SDP file on LabMC. So it has to be recompiled.
Yes.
Okay.
It does be recompiled, yes.
With the new URL.
Yeah, it's needed.
And then it will become not compatible with all the pendulums we have presently.
Yeah, it's needed some migration, correct.
But it will be a one-by-one migration.
yes.
Yeah. But as we expected that the multicast each partner has deploy the own multicast, so it's needed anyway the new build. So
yes, even if we only change the URL for the server, you will need the recompilation.
Yeah.
So
yeah, that's the point.
Yes, that is needed. We need to recompile everything if we want to use the old ones and the new ones.
Okay, thank you.
Okay, so just for completion, I showed you the Raspberry Pi, but now the streamer server is getting the information that is being published, and now, as you can see, we got the access back of the video streaming. So I think this explains most of the subject. If there is some alternative, we are open to suggestions. If someone knows something that works better with this and can adapt to both approaches, all suggestions are welcome.
Yeah. no, that's it.
Don't stop and share.
Okay.
Just one thing. The streaming server is only for streaming the video. If you wanted to run a kind of another technology or do that, you can do, because it's not like don't run any of particular code of us. Okay, we only need the URL from the video. Okay.
Matrola, I don't agree, because you need to, in the case you are running through the application, you need to have it available as we have presently as a plugin of VLC over Java.
Yeah. We just need to run as a RSTP.
Sorry?
We just need to run as RSTP protocol.
Yes, but you are not supporting the SDP file, which is presently what VLC uses. No? Presently, you are opening a SDP file through RSTP protocol.
Yeah.
And with your technology, you are not opening any more SDP file. It's something else. I don't know exactly what it is, but it's not an SDP file. And I'm not sure if the plugin of VLC that you are using on Java can support this new
It's not
frame.
don't have the extension of SDP file, because this is a problem with the streaming server, the distribution. If you at the name you have the .stp, they say that the name is not valid. So you don't have an extension, but it's a SDP file. Okay, you understand the point?
Okay, but you have tried already with the Java or the VLC plugin on Java that it works.
For this, yeah.
Okay.
Yeah. Okay. Cool. I hope that is clear. So as you can see, we didn't really use anything from scratch for the streamer video. We're just using tools that are already available, and you can explore that too. So we are distributing the streamer also via the Git if you wanna use it. The solution that we have created, and that we are explaining here. So here are the commands for FFmpeg and GStreamer, like João was saying. You can use these to set up the video streamer on the Raspberry Pi. These instructions will also be present in the wiki, in the corresponding section for the video. It still needs to be updated, but as soon as we do it, we will update also this file so that all information is available everywhere and coincident with from all sources. So it's fairly simple, like João said. It does require you to know a little bit about Docker and how to set it up again. So please be mindful of that. I don't know if you have any more questions at this point. I could eventually, before moving on, I can also ask João Cortes to rerun the deployment of the Docker files if you want to watch it again. Just to let you know that we've also made a few pages that João has also briefly showed you in the first time, where we can turn on the logs for each application and to view the logs and understand if something is going on with any application. You can also have the need to enable the debug modes for any of the applications. So we also leave some instructions or some tips on how to do that if required. And also there's a client administration for WebSwing if you also want to debug the client eventually. And this has got a bunch of options that you can use and allows you to do a number of things, even including if you need to view what's being made at the client by any specific user, you can actually view on your screen on the debug mode what the user is doing live. So this is a very interesting tool if you need to have some debug and more advanced features or anything like that. So also take a look at it if you are picking this up from a technical point of view. So I would make a summary, but before that, I would perhaps ask again Cortes to just briefly run again the deployment of the Docker images, so just so that we can see it again, and if we have any questions, you can also pose them and try to pay attention on the commands that he uses and what he is doing also. João, would you like to go for it again?
Okay, I can show stopping at the individual service and starting again.
Yes, that's
Can make a simple examples different from the one that I ran. I ran a complete shutdown of the server. Okay, so so I'm going to increase a little, and now okay. So now I'm at the place. We have all the services running from before, 58 minutes ago, as you can see. It is up. It shows the ports that are being used internally. If they are used, if you are getting exposed at the server, you will have something like this, saying what will be the bind address and the port that is being exposed in the host, and what port it is transporting for inside the container. Same here, we have the rec proxy that has this exposed, the 80 port and 443 port, and then we have the multicast that is exposing 9001 port, because RecWeb is in the same server. If it were in other server, we would need to expose also the port 25001. So now if we want to stop a service, for instance, we want to stop the client, we can do a docker stop rec client. For instance, we can stop the client as easy as this. Okay, so now as you can see, rec client is down. We can see it here, but it says that it was exited with an exit code. This usually is the exit code that is returned, and we can also remove it completely. We can remove the container. There is no more rec client at this server, and as we showed, we can start only the client if you want to. I can show you that how Docker works when the server is already, when all the other services are updated and does not need. We can also do the startup command that we did before, and all it is going to do is saying that every other containers are up to date, so no need to recreate, and only recreates rec client. And as you can see, rec client is starting up again. As you can see, it was now that I did this, and if we want to check, we had a connection error, and if we connect again, okay, so okay, sometimes is not. It was my session that was okay, so maybe I need to open some issue with cache. Let's see if this works. Okay, now starting up. Now we have web sync. I also can show you the console that Rui was saying. We can manage. You have to be an admin to do this. An admin user. You can also set users to privileged users to use this. Not every user will have access to this. And now, if we go to the sessions, we have a configuration, logs. We can see everything in this console related to WebSwing and client. And as you can see, my session is up. We have the session saying how much memory I am using, CPU. And if I run something that uses more processing power, it's going to push a little more. The bandwidth is using, the latency. You have all this information in this console. And then you can also see, as Rui said, you can also see the session running real time. So now if I want, I go here and say, I want to run this. And then in the session, as you can see what the user is doing. It is useful to check problems that the user is having with the application. You can see this is real time. We can check the results or the description, the results. Okay. Results is going to be shown. As you can see, it's running and I'm seeing what the user is doing. So it's very useful to check the issues that can be happening with the sessions or with a special user. You can always check here. And as you can see, the latency, the bandwidth regarding only this session, not the application server itself. It's the session. If you have more users connected, you will have more information regarding the CPU memory that the user is using. Okay.
But just you are saying that one session consumes like 15% of CPU. This means that 10 users, we are done.
No, because normally you don't have only one CPU. Normally the usage of the CPU is going to be shared with if you have 8 CPUs, you can have 800% of CPU usage.
Yeah, I understand, but even so, normally we can have up to, if you have like in a stress session, you can have like, we have 20 experiments. If you have 3-4 people connected to each experiment, you'll be like 60 sessions.
Okay, but that way maybe we can have multiple WebSwing servers, more clients. We can share the load with others. This is showing 12% CPU, but we can try later to check that issue. Yesterday we had 10 users.
How many pendles will be in each multicast?
No, this is not the point. Is in the future. I mean, this is not really scalable. Of course, we are going to have like 10 pendulums per region, and so this is not the big issue. Is when the laboratory will start to grow, then it will become an issue.
Okay, in that time we can. There are another possibilities. Even WebSwing has not this version, I think, but WebSwing has a version that has cluster mode, and that can also be explored. But I don't think. Yesterday we had almost maybe 20 users connected at the same time, and the server was not using that much CPU. No, I don't think that we could have that issue. And the great thing about this application is that every session has a dedicated JVM. So if anything happens, WebSwing is not going to crash on error. What can happen? What will happen is that the sessions can be killed by any case. So the server is like protected from that. That's why we also define in the properties of the application. We also define the maximum users that are allowed, the session timeout. We can configure that, and maybe we can escalate. We can check to escalate, but I don't think that it will be a great issue regarding the quantity of users that the number of users that are going to connect to it. But we can check that also later. We made the experiments with a lot of users and did not have any problems so far.
Yep, that's true.
Okay, so I don't think I think I explained the starting up the process, but you can also start the process by the process name, as Rui showed before. You have the possibility of starting a service like Docker Compose up and say that you want to start up only WebSwing or only the rec web. And if the server is already up, as you can see, this one as another dependencies as rec database and the rec multicast. So as you can see, you can set dependencies that if you start up LLabs rec web, it will also start up multicast and rec database. You can also define that in the Docker Compose files. It is as flexible as that. So I pass to you, Rui.
All right, thank you. Thank you for that recap. And also in the spirit of recapping and kind of wrapping up the session for today, let us know if you have any questions. Just post them. I think that I'm not viewing the questions right now, but also in the spirit of summarizing.
I think, sorry, Rui, I think Ernesto asked the question about multicast. Is there any issue to consider for multicasting across different subnets?
You can go ahead and answer that.
Okay. So I don't think you will have an issue if you have the correct routes. If you set the correct routes, I don't think you don't have you have the page that Rui showed in the slide before. Okay, that needs all the ports that need to be set. So I think up.
This one?
No. More a little. I think it has an image associated with it.
Right.
Okay. Yes, right there. Yes. So here you have a list of ports that you need to specify, and when you set up the routes, you need to set up the correct routes to the different subnets, so that the traffic is going as expected.
Yep. Exactly. Thank you. Hope that answers.
And I forgot. And that can be also defined at the Docker Compose files. You can also define the networks that are going to be used to outside the containers to redirect the traffic. So it is just the way of configuring the Docker Compose files. They have a specific section for networking. I don't think if that answers the question, but you can.
Yeah. Okay. Thank you. So we've been through quite a bit these last couple of days, and I leave you here with a short summary to remind you right now. If you want to set up a Pendulum, you need to ask us for the hardware server. This is how the current system was working thus far. So we had a shared folder. We would put the rec hardware server in there, and then you could handle the deploy, and the instructions are on the wiki page. From now on, we propose that partners are able to create your own pendulum using the script that we have shared here. That you are able to build a project, that you are able to deploy the hardware server, and then deploy the other components on your own servers. And of course, we'll be here to help you. The proposal, we'd like to leave a proposal for the project, and this also for the managing, for the coordinating partner. We will try and create a forum for Q&A. I think it could be useful. Also, let me know what you think of that, and Anna. Maybe if we could create this forum for Q&A and sharing information more directly and more on a regular basis and in a more live basis or day-to-day basis, this could really help all the partners get their bearings, and it should be interesting to get the project going and get a real sense of community onto this. So let us know what you think, and we'll be trying to push through that. So, and then here on the right-hand side, I'll leave some 7 simple steps to deploying the pendulums, which would be check out the project from Git, create a new pendulum using the script, verify if there's any changes you'd like to make or not, then build with Unt and Maven. Instructions are at the README file. Then take the zip for the hardware server and deploy it on the Raspberry Pi. Instructions are on the wiki. And deploy the client and multicast at your own server. Some instructions to get you started are present in this document. Take a look also at Docker information on how to use Docker. Also the same with the video streaming server. So it's shared on Git. Some instructions to get you started are present in this document. But of course, step number 7, maybe the most important, call us if you need to, let us know what you need, and let's try and work together. So that'll be it for now. The idea is to create also, just let me leave you this small little image, that we can create and distribute as many servers as possible with your own servers across the project partners, whether they're holding just a multicast and a client, whether they're holding just a video streaming server, whether they're holding the whole shenanigan. So the idea is for us to have a main server serving the rec web at IST. This can also change if necessary, but this would be the idea. But I leave you here with a simple idea that a partner can house in their own infrastructure different options to share the load and to manage the load between all of us, and so that we can build a nice and robust network, and that we can all share this experience, this worldwide experience. And that's it. For the future, we have some ideas to develop a little bit more the interface and the way that we can manage the information shared between the partners, or in this case, every time, like João showed you, every time we have a new experiment, we need to build a rec web. The idea is that this process can also become a little bit more simpler. So we'll be working on that in the near future, hopefully with some news for that. But if you want to have a crack at it eventually, go ahead, and we won't stop you. You're more than welcome. And yeah, that's about it from our side. I remind you the support email for getting in touch with us. Use it at your own discretion, and we'll be here on this side to answer any questions. All right, that's it from our side.
Okay, Ruud, thank you very much. I don't know if there is questions from the audience. They were being posted in the chat in the meanwhile. Yes. So as I told you before, I kind of asked Rui and João Cortes to prepare a reduced version of these videos, because part of them are not quite so interesting. So we were just going to edit, cutting some parts and maybe putting some slides that could highlight what happens in the middle, so people could follow late this activity, and probably they could be part of the mini MOOC series that we are preparing for deploying the experience. Okay, so this is one of the IST deliverables. Okay, so if there is no questions,
I will stop recording.
we will adjourn the session, and thank you for being here. Some of you probably will meet by the 11th of March in the meeting of the managers, and we'll see and have a nice, in your case, afternoon, in our case, noon. Okay, bye-bye to everybody.
Bye-bye.
Bye-bye, everybody. Thank you.
Yeah, bye.